Hey folks, welcome to the channel. My name is Chad, and in this video we're going to talk about JavaScript promises. We'll be looking at how to create them, how to work with them, and a few gotchas you might want to be aware of. Why do we need to talk about promises? Well, in my experience, they're an integral part to many apps and APIs. Even the most basic things like making a network request, if you're using the browser's fetch method or Axios or something like that, those leverage promises, so if you need to use them, you'll need to know how to work with promises. And, of course, if you're joining a team or looking to join a team, there's a good chance that if they use JavaScript, they're going to use promises, and it's really important that you know how to work with them so that you can join that team and be productive. Now, if you've ever used callbacks before, you may have run into a situation called
callback hell,
where you have callbacks calling other callbacks, and then they're calling yet other callbacks, and you just don't know how to trace through the code, and it becomes impossible to diagnose and triage bugs. And promises can help get around this obstacle. They can help reason about asynchronous code by providing asynchronous looking syntax. So those are just a couple of the affirmative reasons to look at promises. But it is important to note that there are a couple of gotchas, and we'll take a look at those in this video. Now, before we dive into syntax, what is a promise in JavaScript? Well, in plain English, it is a promise to do something with a result at a later time. And that result may be successful or resolved, or unsuccessful or rejected. As an example, let's say you order something from Amazon. Amazon has promised you to deliver your goods to your house. Now, if they deliver them successfully, then we would consider that promise resolved. You have the packages, you're good to go. If Jeff Bezos decides to send your packages to the moon on Blue Origin instead, then obviously you don't get your packages, and we consider that promise to be rejected. Alright, with that out of the way, let's dive into some syntax. Okay, so we'll start out just creating a promise, and we can do that using the promise constructor like this. And the promise constructor accepts a function, and we'll use an ES6 arrow function here. And this function itself accepts two arguments, resolve and reject. And these functions signal to the promise that the promise was completed successfully or unsuccessfully, respectively. So if we were to call resolve with the message success, then we are telling the promise that it completed successfully. And similarly, if we call reject with an error, then we'll signal to the promise that it was completed unsuccessfully. And we'll leave this commented out for now, but we'll see that in a moment. And in both of these cases, resolve and reject tell the promise that it was completed or fulfilled. In other words, it was settled. So until these are called, the promise is said to be pending. So how do we get access to these results? In the success condition, the success message, and in the failure condition, the error message. To do that, we'll need to use two of the methods on the promise itself. The first of which is then, and this handles the successful condition, and this accepts a function, and the argument to this function is whatever was passed through the resolve call. So in this case, it's just a string, and we'll come down here and we'll just log this out. We'll say in the then with the message. And I'm just using the template strings here. If you're not familiar with those, I'll make another video on them. It just makes it a little bit easier than string concatenation. Okay, so if we save this, then over in the console on the right, we can see in the then with the success message. Perfect. So we got access to the successful result. Now, what happens if we reject the promise? So we'll just swap these. And if we save this, then you'll see we actually get an uncaught error in the promise. This is not a good scenario. We want to catch and handle that error. So in order to do that, we'll use the catch method. And similarly to then, this accepts whatever is passed through reject. In this case, it's also a string. So we'll do something similar here. And we'll say in the catch, and we'll just log out the error message. So if we save this, Now we don't see the error anymore, so that indicates that we caught and handled that error condition. We do see in the catch with error as the message. Perfect. So one thing to notice here is that these methods then and catch can be chained, and that's because both of them implicitly return a promise. And this implicit promise return will actually be important when we talk about some of the gotchas a bit later. In addition to then and catch, there's also one additional method that we can use, and that is finally. Now, finally is executed when the promise is settled. So that's either resolved or rejected, just when it's completed. Technically, you can place finally anywhere in this chain, or even have multiple in the chain, but generally that's not very useful and actually introduces some issues that are outside the scope of this video. So generally speaking, they should be placed at the end of the chain. So if we just add a console log here, we'll say end finally, and if we save that, we can see in the catch with the error message and then in the finally. Now, why might you use finally? In my experience, finally can be useful for any sort of cleanup. So if you want to do something or some work at the end of the promise chain, whether or not the promise was successful, that can be a really good use case for that. So if you want to send off some logging or analytics or whatever the case may be. One important thing to note is that finally does not accept any arguments. And seeing these in the structure here, then, catch, and finally, you may have noticed that they're very similar to try, catch, and finally with synchronous code. And as you're learning about promises, I think it's fine to think of these as analogous across asynchronous and synchronous code, unless you're using async await, but that's a topic for a different video. If you're interested in that, let me know in the comment section below. Okay, so that's the core syntax of creating and working with promises, but really quick, there's actually 2 additional ways to create a promise, and these can often be useful as well. So we'll just come down here and we'll say resolved promise, and these methods are actually on the promise prototype. So we can say promise.resolve, and similarly to this resolve and reject, we can pass whatever we want to in here. So we'll just say success again. And then in similar fashion, we can say rejected promise and assign promise.reject. So these 2 alternate ways of creating a promise can be helpful in a couple different scenarios, but a common one is when you want a function to return a promise, but the async work that necessitates that promise is conditional. So we can illustrate that with an example here. So let's create a function, call it maybe make network request. So we may or may not make a network request, and we'll have that accept 1 argument. And if we should make the request, then we'll return a new promise. We won't use reject in this case since we're just going to resolve it for this example. And let's use a set timeout. Since promises help us work with and reason about asynchronous code, we can simulate that asynchrony here with the set timeout. And once that timeout completes, we'll just say resolve the message or resolve the promise with network request succeeded. And what happens if we don't want to make the network request, but we do still want to maintain the promise API of this function? Well, in that case, we can do something like this, where we say return promise.resolve with the message no network request needed. Okay. So to use that, let's say maybe make network request. We'll say true, we do want to make a network request, and then to get access to the results, we'll use the then method, and we'll just console log that out. And real quick, let me just comment this out. Okay, so let's save that. Now 3 seconds go by and we see network request succeeded. So that indicates that we did make the network request. Okay, so what happens if we change this to false? So in this case, we're not going to make a network request. So we'll save that and we see immediately no network request needed. This is really important and can be useful because let's say whatever code is in here is your app, and there's a data service that handles data retrieval for your app, but that data service also has a caching layer. So you can imagine this function as the data service, and maybe you have the data, maybe you don't. If you don't have the data, you'll need to make a network request for it. If you do have the data, you can just return it immediately. Now your app doesn't necessarily need to know that there's a cache, but when the app asks the data service for the data, it still wants to use a promise-based API. In other words, it wants to do a .then and get access to the results. So in this case, we can use promise resolve to our advantage to maintain that promise-based API. Okay, so before we move on to some gotchas, there's 3 additional methods on the promise prototype, and we'll talk about those real quick. And these are the all method, all settled, and race. So we'll say Promise.all, Promise.all settled, and Promise.race. Now each of these methods accept an array of promises, but each one of them behaves a little bit differently. So we'll look at Promise.all first. Now in this case, Promise.all resolves when all of the provided promises have resolved, or it rejects when any single one of them reject. So it's kind of an all or nothing in this case. So we'll use the same promise resolve that we did before. We'll say resolve 1, and we'll add another one to the mix here. And we can just do a then directly off of this since it itself returns a promise. And if we console log the result here, save that, you'll notice that it actually returns an array. So this can be really useful because you get access to the result of both promises, or all promises that were passed to the Promise.all function. And you might use this in a case where you need to make a few different network requests or do a few different asynchronous things that aren't necessarily related to each other, but you need to wait until all of them are complete successfully until you can move on with the rest of your work. So that's the kind of the base case, the happy path, so to speak. And what happens if we reject one of these? Now, since this will be an error condition, we do need to add a catch. And we'll console log the error. Now, if we save that, oops, you'll see reject 1. So that's the result of this one. And I had mentioned that Promise.all resolves when all of the arguments resolve or one of them rejects. So in this case, we don't actually know what happened to the first or second promise. We just know that one of them, in this case this one, rejected, and therefore it's all done. Okay, so that's Promise.all. I'll comment that out for now. What about all settled? Now again, this one accepts an array of promises, but it's got 2 key differences from Promise.all. The first one is that it resolves when all promises have resolved or rejected. In other words, when they've all settled or they've all completed. The second key difference is that the argument provided to the then block actually gives you access to some additional information, and we'll see that in just a second. So let's take a similar approach as before. Say resolve 1. resolve 2, and we'll add this reject in here, and we can do a dot then with the results, and we'll just console log those out. So if we save this, now we see, similar to Promise.all, we do get an array. So we get the results of all of the promises, but in this case, we're actually getting the result of all of them, even though one of them rejected. And if we look at the structure of this result, it's a little bit different than what we got with Promise.all. You'll notice that it comes with 2 properties per result. You get a status, which is either fulfilled or rejected, and a value in the successful case, and a reason in the unsuccessful case. So this can be pretty useful to determine which ones completed successfully and with which values, and which ones errored out and why. Now, in my experience, I don't typically use all.settled very often, but it does have a nice API and it can be helpful for certain scenarios. All right, so let's move on to the final one here, and that is Promise.race. Now in this case, again, similarly to the other ones, it accepts an array of promises, but for Promise.race, it will resolve with the result of the promise that resolves first. So let's say we have a function create timed promise, and we'll have that accept a message and a timeout milliseconds. And in here we'll return a new promise set a timeout and have the timeout be equal to the passed in timeout milliseconds. And once that timeout completes, we'll just resolve it with the message that's passed in. Now let's invoke these functions. So create timed promise, and remember this will return a promise, so that's an acceptable usage of this API here. We'll pass in promise1, and we'll say 1000 milliseconds or 1 second. We'll do that one more time, promise2, and we'll say this one will resolve in 2 seconds. And to get access to the result, we'll do a dot then, and we will just log out which promise1 with the result. Okay, so save that. And it says which promise1, promise1. So in this case, promise1 completed first because its timeout was shorter than promise second. So in effect, it won the race. Now if we switch this, just to prove that, we'll change that to a longer timeout, save that, and after 2 seconds we see which promise won, promise 2, because that timeout is now shorter than this one. So this can be really useful when you only want to spend a certain amount of time doing something, such as fetching data, for example. Now let's say you need to fetch some data to show to the user, but you don't want the user to wait too long. You could use Promise.race to effectively have a network request compete against a timed promise, which is exactly what we're doing here. We just do a set timeout. And if the timed promise completes before the network request does, then you can show an error, and you're effectively capping the length of time that the user will spend waiting for that data to come back. All right, so that was a deep dive into promise creation and syntax and some of the methods associated with them. Now let's take a look at some of the things that folks commonly get tripped up on when working with promises. So we'll just comment all of that out, and we'll move over to this file. Now the first one is that the placement of catch is critical, and really it extends to the placement of then, catch, and finally, but specifically catch. So let's just create a basic promise here. I'll just use promise resolve. And then we'll come down here and say promise.then. And we'll log out that we are in the first then. And then we'll use this catch in just a moment. But we'll log out in the catch. And we'll add one last then block down here. And we'll say in the second then. So if we save this, we see in the first then, and then in the second then. So it's important to note that this catch block is actually skipped when there's no error condition. And remember how we mentioned that then and catch implicitly return a promise? That's why we can actually chain a then off of a catch as well. So that's a added bonus there. But what happens if we reject this promise? So let's save that, and we'll see what happens. Now we see in the catch, in the second then. Notice here that this first then is actually skipped. The catch is not skipped, and the final then is still executed. So this is really important because if you need something to happen specifically before an error might occur, then maybe you want this then to be placed above the catch, or maybe you only want to do some work after you know there's a potential error. So in that case, you might want to put the catch block at the top. The possibilities are kind of endless here, but the important thing to note is that you just need to be a little bit mindful about the order in which you put these methods. All right, so the second gotcha that has tripped me up, definitely, and trips other people up, is that you need to keep the promise chain going. And said another way, it's really easy to forget to return a promise from the then block. So let's take a look at that example. We'll comment that out. Say keep promise chain going. Now, actually, I'll just come back here and grab this function. Uncomment that. And let's get rid of this for the time being. And we'll just say 2 seconds. And we'll add a console login here. Resolving promise with message. Just so we can see when we're about to resolve that promise. Maybe make this a little bit bigger here. We'll just get rid of that file explorer. Okay. So now if we invoke this, we'll create a promise with the message promise1. Then we can do a then. And let's console log this out. In first then with message. Now, let's call this again, create timed promise with the message promise2. And we'll add another then to get access to that. We'll say in second then with message. Whoops. Message. There we go. Okay, so before we run this, you might expect this then block to say something similar to the first one, where it will say in second then with message promise2, the result of this timed promise. Now let's save it and see what happens. Okay, so after 2 seconds we see resolving promise with message promise1, so that's what happened when the promise or the timeout completed. And then we see in the first then with message promise1, so that promise completed, we got into the first then. Then we created this timed promise, this promise2, but you'll notice that we actually see in second then with message undefined, and then later we see resolving promise with message promise2. So there's two things to note here. Number one is that we don't see in second then with message promise2. We see undefined instead. And the second thing is specifically about this undefined. So this is really important to understand, and that is whatever value you return from a then block will be passed to the next then block. And if you don't explicitly return something, the return value will be undefined, since that's the default behavior of a function in JavaScript. So in this case, not only are we not getting access to the resultant value of promise2, but it actually gets worse. This promise chain isn't waiting for promise2 to complete at all. Let's illustrate that and see how we can kind of see what's going on there. So we'll add back in this timeout milliseconds. And let's say 0, and we'll just say 5 seconds there. We'll save that. And we see all these messages here. Note again, we see undefined, and then 5 seconds later, we see resolving promise with message promise2. So in this case, promise2 was resolved after the chain completed, and we didn't get access to the results. Why is this so important? Not getting access to the result of the promise isn't really much of a reach to understand as an issue, but breaking the chain of time can have disastrous consequences. Now, this chain is a chain of time. Each piece of work that happens in create timed promise happens over the course of a certain period of time. If you break that, then that can have unintended consequences and can lead to really hard to find bugs. Now let's say you need a network request to complete before executing the next code. In other words, executing the next then block. Failing to return the promise in which the network request happens will cause it to happen independently of the promise chain. That's what we saw here, where promise2 was resolved after the promise chain fully completed. The rest of the chain will continue regardless of whether your network request was successful, failed, or even completed. So in effect, this promise that we fired off here, that's kind of just happening off in the ether. It's dead. We don't have access to it. We don't know if it resolved or rejected. That's bad news. So let's fix that. We can just simply add a return statement there, and we'll save that and see what happens. So we see resolving promise with message promise1, in first then with message promise1, so we got into here, and then we created the second promise, and 5 seconds later we saw that the timeout completed. That's this message here. And then we see in second then with message promise2. So again, it's really important to remember that you need to return any promises that you're creating inside of these chains. Now, the last issue you might encounter with promises in JavaScript is that they cannot be canceled using their native implementation. Why is that an issue? Well, let's say a user navigates to a page in your app, and in order to show the page, you need to fetch some data, and you use a promise to do that. Before the promise completes, in other words, before the data comes back, the user presses the back button and navigates away from the page. Now, even though the page is torn down in this case, the promise chain still exists, and all code in that chain will be executed. This can be particularly problematic in React apps if you're trying to do something like set state in any of the then blocks. At best, you'll have a potential memory leak. At worst, you're going to probably have a reference error that crashes your app. So cancellation seems really useful, but why hasn't it been added to promises? There is actually a TC39 proposal to add that functionality to the ECMAScript spec, but it's only in stage 1, and it's kind of stagnated for a couple years, I think since 2017, so it's not really likely to proceed past where it's at right now. If you're curious about reading up on that, you can Google TC39 promise cancellation, and I'll also leave a link to that in the description below. If you really want to have cancelable promises, there are some libraries such as Bluebird that add that functionality, but in my opinion, there are other often better non-promise based solutions that don't use a deviation from the ECMAScript specification. Unfortunately, those solutions are a bit outside the scope of this video, but keep an eye out for a future one or a future series on the observer pattern where I'll talk more about that in detail. Alright folks, that's all I had on JavaScript promises for today. Thanks so much for watching. If you enjoyed this video, please be sure to smash that like button, and if you want more content from the channel, make sure to subscribe. If you had a question about this particular video or a request for a certain type of video or something like that, please feel free to comment down below. I'd love to hear from you. And with that, thanks so much for watching, and we'll see you next time.